Hi there, welcome back to the formulaic approach. Now let's talk about redox reaction. I promise you by the grace of God, by the end of this video, you are going to understand redox reactions so well that you'll be able to teach it to someone else too. Just follow step by step and follow till the end. I enjoin you. Now, what is redox reaction? What I'll do is I'll try to go over series of definitions like in chronological order, kind of like the way the definitions evolved. Okay, so let's start with the first one, which is the fact that first, the word redox actually stands for reduction and oxidation. Now, one thing you must know is that in a reaction where reduction occurs, oxidation also occurs simultaneously. They kind of seem like equal and opposite reactions. Is that clear? All right. They're actually equal and opposite reactions. That's what they are. All right. So they take place simultaneously in the same reaction. So the first definition I want to give to you before we talk about balancing. The major problem you have is balancing, I know. I'm going to teach how to balance redox reaction. Anyone in this world, in both acidic and basic medium. I hope you trust me. All right, but let's start from the scratch so that you know how it's building up. And it's going to make sense to you at the end of the day. Because there are tricks and there's techniques that people teach that make it look like you have to calculate some things before you do some things. But by the time you know this chronological definition, you are going to be able to it's going to come easier to you. That's just the point. So what is oxidation defined as? The word oxy comes from oxygen, right? So the first kind of definition they probably gave oxidation was that oxidation is the gain of oxygen or the addition. So oxidation was initially said to be the what? The addition of oxygen. Addition of oxygen. Let me write it in full, oxygen. So what will reduction be? Reduction will be the what? So I'll just put, okay, reduction will be the what? The removal of oxygen. So what that means is that if you see a chemical reaction where oxygen has been removed, it means it is reduction. You see a chemical reaction where oxygen has been added, you call it what? Oxidation. All right, so for example, let me give you an example like, look at this example. If I have something like this, let's say zinc oxide, Jesus Christ is Lord. So early. Okay, I hope this is clear. So, for example, if I have a reaction, okay, please, because of the light, I just want you to know. Okay, look at this reaction. Let me give you a half reaction like this now. Look at this. If I have SO4, 2 minus, to SO2, for example, what kind of reaction is this? Is this oxidation or reduction? Now, looking at this, you see that oxygen is 4 here. There are 4 oxygens here, not this. This is charge. The 4, I'm going to show you how to deal with that later. Oxygen is 4 atomically here. There are 2 atoms here. What happened? There is reduction in the amount of oxygen. So this is not oxidation. This is what? Reduction. This is a half reaction. We call it reduction half reaction. Is that clear? Reduction half reaction. Now, what if I now show you something like this? What if I have something like this? To go to Cr3 plus, for example. If I go from here to here, oxygen is here, no oxygen is here. That's also what? Reduction, because oxygen has been removed. Is that clear? Good. So that's what oxidation is and reduction is. So oxidation is when there is addition of oxygen. Look at this chemical reaction, for example, MnO2 to Mn2O3. Look at it. Oxygen is 2 here, oxygen is 3 here. It means more oxygen has been added. So this will be called what? Oxidation half reaction. Oxidation. Is that clear now? So that's what redox, that's what, on the basis of oxygen, that's how we define oxidation. Now, How do we now, what's the second definition that was given to oxidation? When they reacted with the acids and substances containing hydrogen, they saw that oxidation could also be defined as the removal of hydrogen from something, while reduction was defined as the addition, which is the opposite, right? The addition of hydrogen. Now, if you look at these definitions, basically, hydrogen is an electropositive element, oxygen is an electronegative element. So it gave rise to the third definition that now says that oxidation can therefore be defined as the addition of an electronegative element. Now, for those of you that may not know what electronegative element is, see, on your periodic table, if you know how to draw your periodic table, just draw this table like this. Call this group 1, label to group 8. Group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, or group O. That's why that's this last side here. Then you now draw your table, like to separate them, okay? Just draw your table like this. Then you now start like this, draw your lines, okay? Draw your lines like this, okay? So this will now, you draw this to here, draw this to here, please. So you now come here and say hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So all these guys in group 1 here, they are electropositive. This guy electropositive. This guy electropositive. This guy can choose between electropositive or electronegative sometimes, but it's mostly electropositive. Is that okay? Then the rest here from here, this one will be electronegative, electronegative, electronegative. That's why you write them and you put their charges as minus. The oxidation of this guy is -3, oxidation of this guy is -2, oxidation of this guy is -1. Exactly. So these guys are electronegative. These first guys here, these first 3 guys here are electropositive. Is that clear? Now hydrogen is a problem though, because it can fit into two groups. It can fit into group 1 and fit into group 7 here. Why? Because in group 1, hydrogen is not a metal, but the remaining guys in group 1 are all metals. Hydrogen is not a metal, it acts as a gas, it comes as a gas naturally. So it can function here because, so it means hydrogen can be H positive and H negative, even though in most cases it reacts as H positive. Is that clear? Good. So that's just electronegative. So I'm now saying that when you add any of those electronegative guys, if you add it to something, that's something you added it to is said to be oxidized. And if you remove it, that substance is said to be reduced. Okay, now let's define it in terms of electronegative and electropositive. So oxidation is the addition of electronegative element or removal of electropositive element, because it's removal of hydrogen, right? Or removal of electropositive. I'm trying to write shorthand, okay? Electropositive element. While reduction will be the removal of what? Electronegative and addition of what? Electropositive. The fourth definition I want you to see is that oxidation is defined as now that's another step higher now. They now start calculating their oxidation numbers. And now saw that, for example, look at this guy I give you here, MnO2, to give you Mn2O4 now, for example, Mn2O4, Mn2O3. For example, look at this guy. If you look at this vividly, you will see that Mn here, what's the oxidation of Mn here? Let's calculate. Mn here is, we don't know, X plus, this is how to do this, okay? We don't know that of Mn, so we'll put X plus, for oxygen, remember the oxidation of oxygen is always -2, but 2 oxygens are given here, so it will be 2 oxygen times each one having -2, okay? Will be equal to, now the total oxidation number here, for for a compound or a molecule that is in the ground state, you will not see any charge there. It means the total oxidation there is zero. That is when you add up all the oxidation number of the individual elements together, you get zero. Does that make sense now? So we know that this will give us zero, then x will be equal to this minus this, 2 times this gives us minus 4. Minus 4 goes there and becomes plus 4. So the oxidation number of Mn here is plus 4. Does that make sense? Good. But now look at this guy here. Mn here is, actually I think there's a minus here in the MnO2. I think it's MnO2 minus or MnO4 minus. Don't worry. When I get a standard equation, I'm going to use that. But let's do that here. Now, what would be the case here for Mn? Mn here is 2, so we have 2x plus, here is 3 into bracket minus 2. Does this make sense now? 3 into bracket minus 2 gives us 6. So everything here is going to give you 0. Okay, because there's no charge here as well. There's no charge here. So 2x equals minus 6, that's plus 6 there. X becomes 3 here. There's a reduction in the oxidation number of Mn. So it means that Mn is reduced. But that's not what I want. Because in this case, we know it's oxidation because there's addition of oxygen. I want to use a more valid equation. Let me use this one. See, we have SO4, 2 minus, to give SO2, for example. What's the oxidation of sulfur here? We don't know. You should know this reduction, right? I want to show you that the oxidation of sulfur reduced, because that's another definition we are going into now. You also know that oxygen is reduced here, right? It means it's reduction too, right? So sulfur is X, we don't know, plus oxygen is minus 2, so 4 into bracket minus 2 here. Everything should give you not 0 in this case. Why? Because there's a charge here. This is 2 minus, which is minus 2. Is that clear? Some students usually ask that why did they usually write the charge, this minus after the 2? Why not minus 2? Why not SO4 minus 2? It's because for those of the one that is plus, for example, if it's Na plus now, students usually, because of their handwriting, some of them might write Na plus. So if it's Al3 plus now, for example, that's also written this way. A student might write like this. If scientists chose this convention, the student might come and write Al plus 3. So you see, there's no difference. It looks like alt 3, right? So, but when you see this Al3 plus, this doesn't make sense. Al3 plus, you know this is supposed to be a charge. You understand? I mean, that's another explanation that I offer them. Okay. So this is minus 2. Then we have x is equal to minus 2 is on this side. Here we'll get minus 8. Minus 8 crosses over to that side to give us plus 8. Exactly. So we have x equals 8 minus 2, 6. So the oxidation number of sulfur in this place is 6. But let's check for its oxidation number here. We see have x plus 2 into bracket minus 2 for oxygen is equal to what's total charge here? There's no charge here at all, right? So that will be 0. That tells you it's in the ground state. Is that clear? So now have x plus here minus 4 is equal to 0. So that x equals 4. What do you see? The oxidation number has reduced from 6 to what? To 4. That's called reduction. So that's why the fourth definition of oxidation is the increase in oxidation number, while reduction is the opposite. That was the decrease in oxidation number. All right. So now, how do we now balance redox reaction? Then the last one, let me give you the last definition. The last definition is oxidation is defined as loss of electron. I'll give you a mnemonic. I've given you in my previous video. And reduction is defined as the gain of electrons. So this is what we used to remember. It's C. Leo, okay? Leo the lion. That is Panthera Leo. Do you remember? Lion. How does it roar? When it roars like this. Grrr. So let's spell that. You can spell it like this. G-R. Grrr. Something like that. So this will mean Leo will mean loss of electron is oxidation. Gain of electron is reduction. Is that clear? Do you like that one? Yes, I know you liked it. But let's go to now. How do you now balance redox reaction. So in order to balance redox reaction, you must first know how to find the oxidation numbers. Okay? Now, I've already showed you how to find oxidation number just now, but I'll treat some examples in order for you to be able to know. But let's take a step first. Now, let's first understand how to identify reduction and identify oxidation. By definition, you can identify them. Is that okay? One other thing you must now know is that the species that is undergoing oxidation is the species that is reduced. The species that is undergoing oxidation is the species that is called oxidizing agent. And the species that undergoes this video is not okay. In the next video, I'll show you how to balance chemical reaction and redox reaction. I will still have to post this video because I've been shooting since morning and I don't want this one to go to waste. So this is what I'll do. I'll now merge this video with the one of balancing chemical equation, but I'll still post this, okay? So that I'll show you how to balance balance redox reactions. Please stick to the end. It's blurry. I went to check now. It's blurry. All right. God bless you as a subscriber.